Okay, problem number 22 on the balancing equations sheet that you're printing for tonight's homework, or part of tonight's homework. I'm going to the second page and working number 22. All of the reactions that include a hydrocarbon, okay, this is a hydrocarbon here. Can you see this on the recording? You can't see me pointing to it, so that's why I did that arrow. All right. And oxygen is always going to give you CO2 and water. Now, this could be C12H12. It could be C3H11. It could be any number here on the hydrocarbon end. Okay? That guy, as long as it's just carbon and hydrogen, and you have oxygen, you're going to get CO2 and water. And sometimes, depending on the ratio of this guy up here, you're going to have to do something that requires you to follow the procedure I'm going to show you right now. So let me get rid of these so I can write other stuff up here. And let's rewrite this. Now, first thing I want to do is look on the left side. I see the C6H16 on the left, and that means that there's got to be 6 carbons on the right. So I'm putting a coefficient of 6 here. And I think probably a lot of you went through this particular process, and then you found out something ugly at the end. We'll talk about that. Okay? So I got 6 carbons. Now, I'm also seeing that on the left side, I have 6 hydrogens. And over on the right side with the water, I only have 2. So how do I make that 6? What's my coefficient going to be? 3. All right. Now, I've balanced. I have the carbon to hydrogen ratio. That is set. That means that everywhere that I put a coefficient, I have to make sure if I change anything with the oxygen to make this all balanced, I am going to have to multiply everything that I have so far in the way of coefficients. So the carbon-hydrogen ratio is set. I am balanced, but I can't mess it up when I try to balance my oxygens. Now, how many oxygens when I multiply 6 times the CO2? Come on, how many oxygens here? I have 12 oxygens. How many oxygens do I have here? Oops, this is 12 O's. I've got to write this in a way that it makes sense. 12 O's. There we go. 12 oxygens. How many oxygens do I have here with the water? 3 times 1, which gives us 3 O's. Now, I have oxygen as my wild card on the left side of the equation. So, how many oxygens do I need to get 15 oxygens? 7.5, right? But you can't have halves. Would 7.5 do it? Would that give me 15? 7.5 times 2 is 15, isn't it? Okay, since I can't use a decimal, what I'm going to do is I'm going to multiply the whole shooting match. Yeah, let's do it with black. I'm going to multiply the whole shooting match by 2. So that makes this a 2 for the C6H12, right? It makes this 6 into a 12. It makes the 3 into a 2. Oops, into a 2. All right. Into a 6. And now, what does the coefficient of oxygen have to be? 15. Are we good? See, I could use a decimal there. The alternative to this is On this number right here, I originally have 7.5. That would have balanced it. So when I multiply this by 2, I get 15. This being the original coefficient. That gives me the 15. And that means that this guy right here was a 1, and now it's 2. This guy here was a 6, and now it's 12. This guy here was a 3, and he becomes a 6 now. All right? Okay, this is the balanced equation for number 15. And let's see how we get this guy balanced out. Originally, we had 1 potassium nitrate, and when we have 1 potassium nitrate, there's only 1 potassium. But over here, we see 2 potassiums. And because there's 2 potassiums over there, we need to put that coefficient of 2 right there. Or the coefficient of 2 goes there to make 2 potassiums. Next, we have to look at the nitrate, the NO3, and for the nitrate to be NO3 with a 2 out front, we have to look over at the right side where we see our nitrate here, and there's only 1 of them, so the coefficient of 2 is required so that we can get 2 nitrates. And then we see the ammonia here was 2 because of that subscript, and when we come over here, this ammonia, there was only 1, and the coefficient that we put here to balance the nitrate also balanced our ammonia. Very, very nice. And then the chromate right here, the chromate on the right, there was only 1, and there's 1 on the left, so the 1 in front of the potassium chromate works just great. And that's the balancing of that guy.